So dear students, we are on the chapter friction, and in the last class I have discussed about some problems based on the theory, that is very basic principles about frictions, that is basically about angle of friction, okay, and about the kinetic friction, static friction, all these kinds of things we have discussed already, and we have solved some problems so that your basic understanding about friction is clear. Okay, so now we will discuss another more important concept about friction, and that is basically angle of repose. Okay, this is also a very popular concept and a very good concept, that is angle of repose. So we need to know this thing. Okay, so our next topic should be angle of repose, and what this actually mean, angle of repose. And angle of repose is only arise, the term angle of repose is only arise when we will talk about a inclined surface. And I have discussed in the chapter Newton's law about inclined surface, and there is some angle called inclination angle. Okay, so if we have a ground or have a horizontal surface like this, and with respect to this horizontal surface, let us take a inclined plane. Okay, and this inclined plane have an inclination theta. That is the angle made by this inclined plane to this ground. Now if we make this complete, it denotes the height, okay, maximum height of the plane from the ground surface. So this theta is nothing but is called actually inclination angle or angle of inclination, you can say. This theta is nothing but angle of inclination. But the problem is that sometimes students confused about this angle of inclination and this angle of repose. This is not are equal actually, but you can say that this angle of repose is just a special case of angle of inclination. In a state or in a situation, we can call this angle of inclination as angle of repose. But angle of repose is not always the angle of inclination. This is a particular case in a very special kind of situation. We can call this angle of inclination as angle of repose. So now let me discuss about this angle of repose. Now let me take this as an inclined plane, and obviously now we will take this plane as a rough surface so that we can include frictional force. In the previous chapter, that is in Newton's law, we have always told about the smooth surface. Okay, but here we will talk about some rough surface so that we can include the friction. So now if we place the object like this here of mass m, then what will happen? What are the forces? What the forces will be acting on this mass more m? One force obviously is mg, and another force is the normal reaction, okay, which is perpendicular to the plane, the contact plane or the contact surface, perpendicular to the contact surface in normal reaction, and this is mg. And from the very simple geometry I have told earlier that if this angle is theta, this angle is theta, this will also be theta. Okay, so mg will have two components, one is mg sin theta along this direction, and another is mg cos theta, that is along this direction. Okay, so now as this surface is rough surface, a frictional force will appear along this direction, that is F. But initially, you know, if the object is not moving, if the object is at rest on the plane, then you know that the applied force, here actually applied force F is equal to mg sin theta, and this F will be equal to small f. You know, the frictional force is the self-adjusting force. I have told earlier that the frictional force is self-adjusting force, so it will adjust according to the applied force mg sin theta. And when mg sin theta will increase, if the angle of inclination will increase. If the angle of inclination is increasing, then obviously you can say that the applied force is increasing as sine theta will be increasing with the increasing of theta. So if you increase the inclination of this plane from this position to this position, from this position to this position, and again if you increase from this position to this position, then theta will increase, and as well as theta will increase, this mg sin theta will increase, and it means the frictional force will also be increased to adjust the applied force. But you know there is a limit of this frictional force to adjust itself, and that limit is called limiting frictional force. That limit is called limiting frictional force. Now you have to be very serious about this point, that as soon as the frictional force will reach to its maximum value FL, then the angle of inclination made by this inclined angle to this surface is called angle of repose. So angle of repose is a special case of this theta, a special condition of this theta, when if we increase theta, our applied force mg sin theta will increase, and for a particular value, up to a particular value of mg sin theta is balanced by the frictional force F up to a certain limit, and that limiting force is called limiting frictional force. And beyond this limiting frictional force that is arised due to the adhesive force between the surface of this object and this inclined plane, and it have a maximum value. It cannot adjust itself after some particular value, and that critical point, that critical condition, that limiting condition beyond which the object will be moving. So at the extreme position, at the extreme situation, you can say, at the extreme situation when the object is just about to slip, that is when this F will be FL, that is the frictional force will possess the maximum value, and at that time the angle of inclination is called angle of repose. So if you want to do experiment, if you take an inclined plane if we can change the angle of theta to do this experiment, what we have to do? We have to choose, or we have to take an inclined plane whose angle of inclination can be changed. So initially, if we take a small angle of inclination, then the object will be rest on this plane. Then if you slowly increase the angle of inclination, then the mg sin theta will be increased, but the frictional force will adjust by increasing its value. Now if you again increase the theta, there will be a limit when the frictional force F cannot balance mg sin theta, and if you increase the theta further, then the object will be moving. So at that extreme theta, if you increase the theta, then you will reach a particular value of theta when the object will be just about to slip, and for that particular value of theta we can say that angle of inclination as angle of repose. So you can say here, when F is equal to FL, then theta will be alpha. Let me take it as alpha, and this alpha is nothing but the angle of repose. This alpha is nothing but the angle of repose. Okay. So if we draw this inclined plane by using alpha, so to avoid this confusion, I am going to do another diagram. Okay. So now let me take this angle as alpha. Now when this angle is alpha, then what will happen? Then the frictional force, basically this F, will be FL. and the other forces are, this will be mg, this will be normal reaction, and this is now mg sin alpha, sorry, mg cos alpha, as this is alpha, so it will be mg cos alpha, and along this direction it will be now mg sin alpha. Okay, so now in this case you can say FL is nothing but mg sin alpha, and you can say n is equal to now what, mg cos alpha, mg cos alpha. Now as you know, FL is equal to mu s into n, that is mg sin alpha, and if we put this n here, then it will be mu s into mg cos alpha is equal to mg sin alpha. So again you will get this mg will cancel out, and mu s will be sin alpha upon cos alpha, that is tan alpha. So you will get here, from here, alpha is equal to tan inverse mu s. Okay, and we have got earlier that lambda is also equal to tan inverse mu s. So numerically you can say this angle of repose alpha is equal to lambda, that is angle of friction, but physically they are different. Numerically you can say that these two angles are same, it would be actually same, but physically they are different, because this alpha and lambda are really to different kind of situation, to different things when you talk about friction. Okay, so this is all about angle of repose. So please don't confuse that theta is angle of inclination, and a particular situation of theta is known as angle of repose. And basically, if you want to remember this thing in one sentence, then whenever you will see this f as FL, then you can say this theta, this angle of inclination is actually angle of repose. Okay, so this is all about angle of repose. Now what will happen if we take another inclination that is greater than alpha, or in your experiment if you increase theta further more, that is beyond alpha, then what will happen? The object will be now moving. So now we have to determine the acceleration of this object through rough surface. We have discussed earlier that the acceleration along the smooth surface, that will be g sin theta. But now what will happen? What will be the acceleration if we take into consideration the limiting frictional force or the frictional force in general? So when the object will be moving, this frictional force, limiting frictional force, will be kinetic frictional force. When the object will be at rest, the frictional force will be static frictional force. So now if we again increase this value of theta, that is beyond alpha, that is cross alpha, the value of alpha. Okay, so now what will happen? Let me see. So that will be nothing but the acceleration along the inclined plane. So now if we take this as beta, and beta is obviously greater than alpha, and alpha is obviously greater than theta. Let me take theta as a general case. Okay, theta is a general case, so you don't need to write down like this. Theta is a general case. Alpha may be theta, beta may be theta. Is the angle of inclination at any situation. But when there is a limiting frictional force, this is called actually angle of repose. And if we further increase this value, or if we take an inclined plane which have the angle of inclination, for which the angle of inclination which is greater than this angle of repose, then what will happen? Then the object will be moving along this inclined plane, and now the frictional force will be treated as kinetic frictional force. All other forces will be same, only the value of alpha will be replaced by beta. So along this direction it will be mg cos beta, and along this direction it will be mg sin beta. Okay, and the acceleration will be obviously along this direction. Okay, so now what will be the acceleration? Let me find out. So this is now very simple. By using the Newton's equation, you can easily find out this acceleration A. Okay, so along this direction, what will be summation F? that will be equal to mass into acceleration. So if you take this as our x-axis and this as our y-axis, then you can write it also summation fx is equal to max. And the summation fx is what? mg sin beta minus fk. This is mg sin beta minus fk is equal to ma. So fk is again mu k into n. So mg sin beta minus mu k into n is equal to ma. So it will be mg sin beta minus mu k, and what will be n? N will be mg cos beta. So it will now be mg cos beta is equal to ma. So mm will be cancelled out. So it will be g common into sin beta minus mu k cos beta is equal to a acceleration. So this will be the acceleration along the inclined plane when the plane is not smooth surface, when the plane is but this is rough surface, so that we can include the frictional force. And obviously if you take mu k is equal to 0, that we have discussed earlier in the chapter Newton's law, then obviously this acceleration will converted into just g into sin beta, because this mu k is 0. So a will be now just g sin beta, which I have told earlier in terms of theta, a is equal to g sin theta. So in that case, whatever you can write, theta, beta, alpha, these are same, because there is no frictional force. So as there is no frictional force, the object will obviously be moving whatever be the value of theta. So you don't need to differentiate between alpha, beta and theta. But here in the friction, that is not so easy. That is not so. You cannot take any value when you talk about acceleration. You have to take the value which will be obviously greater than the angle of repose. Okay.